Data center freight adds a second lead time problem. A transformer that leaves the factory on schedule still has to reach the construction site, and the freight market capable of moving large electrical and structural equipment has tightened sharply. For procurement teams focused primarily on manufacturing lead times, transportation is becoming another source of schedule and cost exposure. Data center developers have spent several years planning around long transformer and switchgear production queues. The next constraint is emerging after that equipment is manufactured. Flatbed, step deck, and specialized heavy haul carriers also serve data centers, power plants, grid projects, and industrial construction, creating competition for transportation capacity that does not appear in an equipment supplier's quoted lead time. Flatbed spot rates reached $2.94 a mile, 40% above last year. D8 Freight Analytics reported national flatbed spot rates of approximately $2.94 per mile in mid-June 2026, about 40% above the prior year and 31% above the non-pandemic 5-year average. Flatbed load activity was roughly 70% higher than a year earlier for the week ending June 20th. FreightWave's Sonar data separately showed flatbed tender rejection rates moving into the high 30% and low 40% range during parts of 2026, meaning carriers were turning down an unusually large share of contracted loads in favor of other opportunities. Data centers are not the only source of that demand, but they are an important one. DAT has linked the market's strength broadly to data center and energy infrastructure construction. From structural steel and precast concrete on the civil side to switchgear, transformers, and generators, once a site moves into electrical build-out, much of it already booked into 2027. The result is a freight segment operating very differently from the still soft consumer and housing markets. Data center equipment competes for specialized capacity. Data center and energy infrastructure freight is also behaving differently from the rest of a soft market. Consumer, retail, and housing-related freight tracks inventory cycles and seasonal demand, and both have stayed weak through 2026. Data center construction freight runs on multi-year capital programs that react less to those swings, which is one reason flatbed demand has stayed elevated even as other freight segments soften. Projects can still be delayed, redesigned, or phased. So this is a directional pattern rather than a guarantee of steady demand, but it helps explain why flatbed conditions have diverged so sharply from the broader market. None of that equipment travels by itself once it clears a port. It still needs domestic drayage and specialized transport for the inland leg, drawing on the same tightened flatbed and heavy haul market described above. The severity of that constraint varies by lane, equipment type, permitting requirements, and proximity to qualified heavy haul carriers. National freight data demonstrates broad market tightness in the capacity data center equipment depends on, though it does not by itself identify which specific ports or corridors are the most exposed choke points, a detail that would need port-level or carrier-specific reporting to establish with confidence. Flatbed and heavy haul are not the same capacity pool. Ordinary flatbeds and step decks, the equipment behind the rate and rejection figures above, typically carry structural materials and smaller components. Large power transformers are a different problem entirely. Substation transformers serving data center campuses can weigh anywhere from tens to hundreds of tons depending on voltage, rating, and design. And the largest units require engineered multi-axle trailers, route surveys, bridge and utility coordination, escorts, and state and local permits arranged well in advance, sometimes with rail or barge movement as part of the route. That capacity is narrower than general flatbed availability and is typically arranged through project logistics providers rather than ordinary truckload tendering. Procurement teams tracking flatbed conditions closely can still be caught off guard by heavy haul availability because the two markets move on separate timelines. Intermodal rail offers limited relief for oversized equipment. Intermodal demand strengthened during 2026 as rising trucking costs pushed more conventional freight toward rail, with monthly growth rates picking up as the year progressed. That relief does not extend to most data center construction equipment. Oversized and out-of-gauge loads, which cover much of the heavy electrical equipment on a data center project, cannot move in standard intermodal containers. They require open-top rail flat cars, Schnabel cars for the heaviest transformer moves, or dedicated heavy-haul road transport for the full route. Intermodal's growth is concentrated in standard dimension freight, which leaves the equipment actually driving flatbed and heavy-haul demand with limited alternative capacity to fall back on. For procurement teams, the multi-year transformer and switchgear lead times already built into project planning are only part of the schedule risk. Transportation planning for the largest equipment typically needs to start during procurement itself, well before a construction contract is finalized, though how far ahead capacity needs to be booked depends on the cargo, lane, and permitting involved rather than a fixed rule. It is the same lesson already showing up across materials and equipment cost planning for infrastructure projects more broadly. The delivery leg is one more structural constraint in an already tight execution environment, and schedules built without it tend to slip somewhere they weren't watching. You've been listening to Sustainability Soundbites by Environment and Energy Leader. For partnership opportunities, please reach out to our team.